Okay, welcome back. This is now part 4 for chapter 7.3. We will proceed straight on to example 13. Okay, and this is still under the topic of independent events. Okay, so for example 13, you have a certain survey and 2,371 adults were asked. You have an adult who is chosen at random. And then we have two events here. C is the event that the adult likes coffee. And D is the event that the adult is called David. Okay. So for letter A, they are already telling us that C and D are independent events. Okay. We are just asked to explain why that is the case. Well, that's pretty obvious, right? Because just because you like coffee, okay, that does not have an effect on what your given name would be. Okay, so again, going back to the definition of what is an independent event. Okay, an independent events are said to be independent if one does not affect the outcome of the other. And in this case, a person's coffee preference by no means affects their name, nor does their name have a direct bearing on whether they like coffee or not. So that would be the explanation for letter A. It's also written in your book. Okay, I just said it, so I won't write it anymore. Now, moving to letter B. Given that the probability of the adult liking coffee is 0.8, and the probability that the person is named David is 0.007. Interpret your answers in context in each of the following. So that means we're asked to find, for I, the intersection of the two. Okay, well, to do this, okay, because your events are independent, we are allowed to perform the following. We can simply multiply the probability of C times the probability of D, again, only because we know and we are absolutely certain that they are independent. You cannot do this if the events are not independent. So always verify, ensure that the events are independent in order to be able to perform this trick, if you will, or process. Okay, so this is pretty straightforward. You just have to multiply them out. And this should give you 0.056. Okay. All right, for II, we are now asked to find the union. Okay, C or D. How will you do that? Well, in this case, we already know what the intersection is. Okay, again, because they are independent, we can say that these two are equal and we know what the intersection is. So in this case, what you will do is you will add the same way you would normally just add the numbers if you had a Venn diagram and you were asked to find the union. Okay, so I would add 0.8 plus 0.007. However, I will subtract the intersection, and the reason for doing so is to avoid the repeating the values. Okay, so let me just write the answer. Okay, because again, just to visualize what I'm talking about, if I have a Venn diagram as such, right, if what's happening here is I have 0.8 is this entire C circle, and then 0.07 is this entire D circle. Okay, if I'm already including the intersection when I added C, when I included the full value for C, that includes the part that D is sharing with it. Okay, and when I included 0.07, that is the entirety of D, which also includes the part that it's sharing with C. So technically, I'm doubling a few things several times because of the shared part. So to get rid of that, to ensure that nothing gets repeated or there's no double or triple count, okay, I need to subtract the intersection to ensure that I'm only counting everything exactly once. Okay, that is the reasoning why if I'm adding the entirety of two groups, but I need to find the union, I must subtract the intersection between them. Okay, I hope I made that absolutely clear. Okay? All right, so that is for part 2. Now I think that I answered that. Okay, part C, we are now asked to determine whether they are mutually exclusive. Well, clearly, they are not mutually exclusive because we have an intersection, okay, from letter A. And in symbols, that's just telling us that the intersection is not equal to 0. And so if it's not equal to 0, it cannot be mutually exclusive. Okay, this reason should be clear enough. And when you are writing your papers, make sure that you put this as part of your reason. Okay? All right. I will talk about example 14 in the next video.